Okay, I'm going to talk about the centre of a group G, which I defined in one of the previous screencasts, and I'm going to assert that that's a normal subgroup of G. So what's the centre of the group G? Well, little z is a member of the centre if, and only if, for all x in the group, x z equals zx. So you'll remember that z are the elements, the centre of the group comprise of the elements which commute past everything. So I'm going to take that and I'm going to multiply it on the left by x minus 1. So x minus 1 xz equals x minus 1 zx. I'm just putting a minus 1 on the left of this equation here. And of course that says that z equals x minus 1 zx. For all x in the group, for all x in the group. So we see this quite a lot. Z equals x minus 1 zx, and that's a definition of the centre. Now, you'll remember the definition of a normal group is that for all x in the group, x minus 1 nx is a member of n. Okay? So that's the definition of an n. This is the criterion for n being a normal group. So is that satisfied for an element z, which satisfies this? Well, of course it is, because if I've got an element z, I can ask what x to the minus 1 zx is, and that's just equal to z. So if I get an element of the centre and conjugate it with any element at all of the group, I just get back to itself. It's kind of, I'm not even shuffling around the elements of the cosets. I'm getting back to itself. So of course it's a member of n. QED. So that's quite nice. That tells me that Z of G is, we proved that it was a subgroup before, but it's now known to be a normal subgroup of G. And I think one of the Rubik's Cube videos talks about the centre of the Rubik's Cube video. Okay, I'm going to stop there. I'll give you some examples of normal subgroups and centralizers and so forth a bit later, but for the moment just observe that the centre of a group is a normal subgroup of that group.